Let's go over Theorem 8 and Example 2 in this video. I have several problems that we want to go over. And Theorem 8 is basically just the same as Theorem 7, but chain rule added to it. So if you have derivative of natural log of x, remember that is simply 1 over what? 1 over x, right? So something similar will happen. We will be given, let's say, make this go up a little bit. We're going to get something like derivative of natural log of u, and u can be a function, okay? Then what we will have is we're going to have 1 over u, but not only that, we will now multiply this by the derivative of the inside function u. So this is what makes Theorem 7 and 8 a little different. This will be used when we have a composition of functions. Okay, so let's look at some example down here. Example 2a, y equals natural log of 3x. This is not just natural log of x, right? We have 3x. So we're going to have to use this chain rule, okay? All right. Y prime is, first, apply that theorem 7. Write down 1 over 3x. You write that down first. And then, immediately, we will now multiply this by the derivative of that 3x. Okay? So, the blue part will stay the same, 1 over 3x. But now if you find the derivative of 3x, that's going to be just 3. And if you simplify your answer, that is, well, the 3's will cancel out, right? Cancel, cancel. Therefore, your final answer is 1 over x. Okay? So we are using chain rule in the next, in these 6 example problems. And I think they are going to get a little more challenging each time, but that's okay. It's the same rule applies. So for example, B, what are we going to do? Y prime is, now I like to always kind of highlight or circle my argument because that is going to be the denominator, right? This is going to be y prime equals 1 over x squared minus 5, but do not stop there, right? We don't stop right there. We are going to multiply this by the derivative of that inside part, x squared minus 5. Okay? I know Chris will probably do this in his head. That's okay. I like to write down my plan. X squared minus 5 is still waiting. But if I now take the derivative of x squared minus 5, that will be 2x. So all I need to do is just put that 2x on top of my fraction. So I will have 2x getting multiplied to that 1. So 1 times 2x is just 2x over x squared minus 5 is the final answer. Okay? So I'm going to try to use an orange pen to write the derivative of the inside function, the chain rule piece. Okay, I'll keep on doing the same thing so that you guys see the pattern. Next one. Let me highlight the argument. This right there, that is going to be the denominator, because this is natural log of that orange highlighted thing. So y prime is equal to, write down 1 over, I'm going to have that trinomial in the bottom. And then that's not just it though, right? Now we're going to multiply this by the derivative of that inside function, 5x squared minus 3x plus 7. Okay? So that means I will have 1 over 5x squared minus 3x plus 7. And if I take the derivative of that trinomial, I will get 10x minus 3. So all I need to do to write my final answer is I will put that 10x minus 3 on top of the fraction, and in the bottom of the fraction will be that trinomial. Okay, so guys, that's what we do. That's what we do. All right. Next one is a little different though. You see how for the first 3 that we did, the big picture was natural log of blah, right? It was all natural log of that orange circled argument. But the big picture right here for D is not natural log. In fact, what's going on here is this. Y is equal to, the big picture is something is getting raised to the 5th power. And that something is natural log of x. So this time, what we have is a power. We're gonna have to use the power rule first. So let me show you how to do this one. So y prime is equal to, I will bring down this 5, okay, to the front. Ooh. I'll bring this 5 down to the front, and I'll write down 5 and keep that natural log of x exactly the same. But what's the new exponent? It is 4. Now we will multiply this by the derivative of the inside function. And what is the inside function? Natural log of x, right? So we will have 5 times natural log of x to the 4th power. That is getting multiplied by, well, remember what theorem 7 said. This is just 1 over x, right? So here's our final answer. We will put 5 times natural log of x to the 4th power on the numerator, and in the bottom of the fraction we will just have x, and that is how you do problem D. Okay, now the next two are a little different. Okay, I want to show you the next two are a little different. I will try to use some properties of logarithms. So for part E, right here, what I will do is, first I will rewrite this. You see, this is natural log of a quotient, right? X to the 8th power is getting divided by 5. I'm not doing derivative yet. I'm just rewriting this. I'm going to rewrite this as, this is the same thing as natural log of x to the 8th power minus natural log of 5. I think this is called a quotient property. If it's a fraction, if it's a quotient, I can separate them with as a subtraction, as a difference, okay? Now, not only that, what do I notice? I see there is 8 as a power, so this can be brought down. I can bring this down to the front, okay? So look, this will come down in front of the natural log. And by doing this, I will simplify. But if I rewrite things this way, the derivative part will be very easy. So this is 8 times natural log of x and minus natural log of 5. So no calculus yet. This is pre-calculus, what we just did. Now I will take the derivative of both sides, okay? So what's y prime? Watch very carefully, okay? I will put d dx, derivative of the first term, which is 8 times natural log of x, right? Minus the derivative of natural log of 5. All right, let's simplify this, okay? Just like example 1, you see that 8 can be pulled to the front, right? So I will have y prime is equal to 8 times d dx, derivative of natural log of x. You okay with that, right? And then I'm going to do minus. Now, hold on a second. Let me go ahead and underline this real quick. What is derivative of 5? I'm sorry, natural log of 5. And you know, natural log of 5 just looks confusing. Is just a constant. It's just a number, guys. You type in natural log of 5 in your calculator, it's going to give you a number back. It's just a number. So what is derivative of any constant? It's just 0. Okay? So that part is gone. Now let's finish this up. Y prime equals 8 times. Now by theorem 7, what is derivative of natural log of x? That is just 1 over x. So your final answer is, if you just multiply 8 times 1 over x, it is going to be 8 over x. Definitely more than the basic ones that we did. It's because we were using the logarithm property to rewrite the equation a little bit before we jump into finding the derivative. So I hope this one made sense, and we can do another example in class if you want to, okay? All right, let's try one more. The same type. You see how f also has natural log of x to the third power minus 4, and that's getting divided by x, right? So I will go ahead and rewrite this too. I'll go ahead and rewrite this as, see, I'm not taking derivative yet, so I'm not putting the prime symbol here. Y is natural log of x cubed minus 4, close the parenthesis, minus natural log of x. Now what I need to do is take the derivative of both of these terms. So what is the derivative of ddx of the first, which is natural log of x cubed minus 4, and then I'm going to subtract that by the derivative of natural log of x. Okay? All right, the first part we're going to need to use the chain rule. So what is the argument? It is x cubed minus 4. So I will need to first write down 1 over x cubed minus 4, right? And then I will multiply this by the derivative of x cubed minus 4. So that's it for the first, okay? What I just did is this much, right? And let's keep going. Minus sign. What about derivative of natural log of x? Hey, that is just 1 over x by theorem 7, right? Okay, let's simplify the green underlined part. But you know, you guys did something way more complicated than this before. You did the difference quotient. So I'm sure you are okay with this so far. I'll try to color code these for you. Green is the green, purple became the purple. Okay, let's keep going. So I'll have my 1 over x cubed minus 4. But that is now getting multiplied by what is a derivative of x cubed minus 4? That is 3x squared minus 0. And then let me keep on bringing that 1 over x down so that we can simplify a little bit, okay? So I will have, the numerator is now 3x squared. The denominator is x cubed minus 4. And we are subtracting these two fractions, okay? And subtracting these two fractions, now we're back to algebra. We're just simplifying rational expressions. So let's think of common denominator. Go get a paper towel, Noah. All right. How about I use the room down here? So if I just copy what we have so far, we have 3x squared on the numerator and x cubed minus 4 in the denominator for the first fraction. And I'll do the minus. And it was 1 over x. So for the first fraction, I will multiply the top and bottom by x. Makes sense, right? I multiply the first fraction by x over x. And now for the second fraction, let me multiply the top and bottom by x cubed minus 4, x cubed minus 4. If I do that, I will be able to get a common denominator, right? So if I put the numerators all together, x squared, 3x, let me go ahead and just circle it, and then I'll write it down, okay? So focus on the numerator. 3x squared times x. You agree that is 3x to the third power, right? And then, why not? Let's go ahead and distribute the negative 1 in. Okay, I'm going to go ahead and distribute negative 1 in. Okay, which will give us minus x cubed plus 4, wouldn't that be? And all over the common denominator of, I guess we can distribute it in. No, it really doesn't matter. I'll just write it as x times x cubed minus 4. Okay, and then all we need to do is simplify that numerator. Give me 1 second. Here you go. If I subtract the like terms on the numerator, I will get 2x cubed plus 4. And the denominator is, I guess you can leave it just like that, but I may just go ahead and write it as x to the 4th power minus 4x to save the room. But that is it. That is how you do the last problem. I gotta admit, the last problem had a little more fun to it, right? Not only that we use the log property to separate these into subtractions. The first part had a chain rule involved, and when we found two subtracting fractions, we had to come up with the common denominator and simplify all the way so that we had a single rational expression for our final answer. But I think you've seen enough of the chain rule example. I will stop this video now, and I will come back for example 3 in another video.